This video will introduce you to making use of the power of prediction for your science demonstrations through the PEOE strategy. And is presented by Catherine Davey and Sophie Lucier, educational consultants at the Lester B. Pearson School Board. Demonstrations are a part of many science teachers' toolkits. Why? In addition to being relatively easy to implement, they're fun, and so they're an effective way to engage students. Demos can be used to increase student understanding of certain concepts. But how can we ensure that once students are hooked by a demo, that the emphasis is on learning about science? How a demonstration is implemented can make a difference towards whether or not the demo is simply entertainment or if it's education as well. A strategy that has proven to help students learn from demonstrations is called PEOE, or Predict, Explain, Observe, Explain. The simplest way to prepare students to use this strategy is to ask them to take a piece of paper and to divide it into 4 sections, and then to label each section PEOE. Students will predict the outcome of a demonstration, explain their predictions, observe the demonstration, and then explain their observations. Finally, students will compare what really happened with their original predictions. We're going to use a demo called Diffusion in a Baggie to show how the PEOE strategy can be used. The first step is to familiarize students with the demo. So I would show students that we have a baggie filled with some starch and water and some iodine that has been added to a container of water. I would also make sure that students had the opportunity to observe what happens when iodine is added to a starch solution. That is, it turns a blue-black color. Then I would show students that I'm going to place the baggie of starch and water in the container of iodine and water and leave it for 15 minutes. At this point, I would stop to ask students to make a prediction. Taking the time to make a prediction is important. Students who predict the demonstration outcome before seeing it display significantly greater understanding. That is, they learn more about the scientific principles underlying the demonstration. Furthermore, it engages students. They want to find out whether or not they're right. I would also ask students to explain their prediction, perhaps through a think, pair, share. So students can clarify their own thinking, but it is also a chance for the teacher to see what kind of misconceptions, if any, exist. But this is not the time to address those misconceptions. First, it is time to make observations, and then explain those observations. So for this demonstration, we'll be able to observe a color change inside the baggie, indicating the presence of iodine, and a color change outside the baggie, indicating that there is now less iodine there. Students will be able to develop an understanding that iodine has moved from an area of higher concentration outside the baggie to an area of lower concentration inside the baggie through the small pores of the plastic bag, but the larger particles of starch did not move. Thus, students will be able to better understand the processes of osmosis and diffusion. Finally, they compare their observations and explanations to their original predictions, and this will help them better understand any misconceptions they may have had. In summary, when you're getting ready to use a demonstration, remember why you wanted to use the demo in the first place. If you want to ensure that there's as much learning going on as there is engagement, then try the PEOE strategy.